Continuing on here, in this middle section, the directions just say solve. They're all two-step equations that we have to work through. As you can see, question 3 looks a lot like 4 and 5 and 6 and 11 and 13. So you're going to approach all those questions in the exact same manner. So I'm going to go ahead and do question 11 with you. Now, when you have these questions that look like fractions, probably what's going to be easiest is to make actually both sides into a fraction. So what I'm going to do is I'm going to write 2 as 2 over 1. And when you have two fractions set equal to each other, that's a proportion, as you know. And the way we deal with proportions is we cross multiply. And that's exactly what I'm going to do to solve this one here. On the one diagonal, I've got 2 times 4. That's going to change into 8. That's pretty easy. Now the other side, or the other diagonal rather, looks like it might be kind of hairy, but it's not. It's 3x minus 1 times 1. Well, multiplying by 1 doesn't change anything, so it's still 3x minus 1. And now it looks like the most basic two-step equation I could pretty much give you. 3x minus 1 equals 8. So we know our rules tell us that x and 8 are in proper locations, but 3 and 1, both being numbers, have to get sent over to that right side. Since the thing with the variable goes last, 3 is going to move last, that means 1 is going to move first. So I'm going to start off and I'm going to add 1 to both sides. That's going to give me 3x equals 9. And now it's just a one-step equation. Undo that multiplication by doing the opposite, dividing. So I'm dividing out 3 all the way across, and x equals 3. Final answer. Again, you can check it by plugging that back in for x. 3 times 3 is 9. 9 minus 1 is 8. 8 divided by 4 is indeed 2. Now, that does leave out some of the questions that are still left in this middle section. Let's go ahead and take a look at number 9, which will help you kind of with the other ones. As you can see, what's left really looks like a bunch of decimal questions and fraction questions, and I think you can handle the decimal questions because most of you are going to approach those with a calculator, which is fine. But the fractions sometimes scare people, so let's go ahead and take a look at one of those, and as I said, we'll look at number 9. So we've got 1/5 n plus 3 equals 6. So we know n is in the proper location, variable on the left. 6 is also in the proper location, lonesome number on the right. What's not so good, the 1/5 and the 3 both being numbers, they both need to get brought over to that right side. So we'll start off with looking at moving 3 there. Remember, the thing that's connected to the variable directly, in this case 1/5, goes last, which means 3 has to go first. So I'm going to subtract 3 from both sides here. When I do that, that's going to give me 1/5 n equals 3. And now this is a one-step multiplying equations problem. And we know from our one-step rules that we studied in the previous chapter, I'm going to solve that by dividing, doing the opposite. But I'd be dividing by a fraction here. And of course, we don't do that. We've never divided by a fraction. Even when we just divide two fractions, forget the equation part, we don't do that. We always multiply by the reciprocal. So to solve here, I'm going to multiply both sides by 5 over 1. So I do that. I've got 3 times 5 in essence. 3 times 5 is 15. So n is going to equal 15. Let's wrap this up by looking at the two questions at the bottom. There are two story problems there. 15, though, is much like questions 1 and 2, so I will leave that for you to do on your own. Question 16 is a little bit different. For 16, you're going to have to refer back to what we did in Chapter 1, translating algebraic expressions. Except this is not an algebraic expression. This is actually going to translate as an equation, which makes good sense since the topic of this chapter is equations. So what it says is 17 less than 4 times a number is 27, and we're supposed to find the number. So if I was talking about 17 less than 20, for instance, you'd be saying to me 3, because 20 minus 17 is 3. Where did we put the minus 17 part? Well, it actually went second, even though it was the first thing we said. So same thing here. What is it 17 less than? 4 times a number. The unnumber is your variable. So that's 4x minus 17, and it's going to equal 27. The word is, something you've seen with me in the Course 2 book, the 7th grade book, Is means equals, and that's also on your reference sheet, and it equals 27. So we're going to solve that now. Variable on the left, lonesome number on the right. So we know the two numbers that are going to move, the two things in general that have to move, are 4 and 17. Since the thing that's directly connected to the variable goes last, that means 17 is going to have to move first. So I'm going to add 17 to both sides. That's going to give me 4x equals 44. The minus 17 plus 17 cancels each other out. And then this is just a basic one-step equation. I'm going to undo the multiplying by dividing out the 4. And when I do that, x equals 11 because 44 divided by 4 is 11.